So all rows consisting entirely of zeros, if there are any, appear at the bottom. I know this seems like a lot, and it's going to be clear once we look at an example. So the example I gave you is what you see here, where notice the first row, the first number is a 1. Every number below that is a 0. So that meets the first two characteristics. Our second row, the first number is a 1, and it is further to the right than this first one. And every number below that is a 0. In our last row, our first number is a 1 that we hit. There's no numbers below that we need to worry about, and it is further to the right than the two leading ones above it. So what we end up getting is this diagonal of 1s with zeros below. The reason we really like row echelon form is that it makes solving these variables very easy. We can rewrite these as equations, where we get x plus 2y minus 2 equals 11, minus 2z equals 11, y minus z equals 3, and z equals -1. Notice z is already solved, so we can substitute it into the second equation. We get y minus -1 equals 3, which tells us that y equals 2. We can now take both of these and substitute them into the first equation, where we end up with x plus 2 times 2 minus 2 times -1 equals 11. And we see that x plus 4 plus 2 equals 11, which means x plus 6 equals 11, x is 5. Thus we have our solution of 5, 2, -1. Notice how easy it was to solve. This leads us into our next topic of Gaussian elimination. We can use the techniques to transform matrices into row echelon form. So what we're going to learn to do is take this kind of augmented matrix and change it into a row echelon form so that it becomes easy to solve for x, y, and z. This technique of altering the matrices like this, it's called Gaussian elimination, and it's using elementary row operations. These are ways that we manipulate our matrix. And you have 3 elementary row operations you can use. Notice we're going to assume A is an augmented matrix, and in the notation R sub I refers to row I. So R1 would be row 1, R2 is row 2, R3 is row 3, and so on. This is what we can do. We can interchange rows. So rows I and J can be interchanged. So we can switch rows around as we see fit, and we do this by saying that Ri is changed with Rj. We can also multiply by a non-zero constant, which we will call C. And we do this by saying that we're multiplying a row by C. Lastly, we can add rows together. And what we say then is that we're taking row I plus row J and moving it into one of those 2 rows, either row I or row J. It doesn't really matter.